Hey guys, so I've been getting quite a few requests around when I will start a YouTube channel or make a video about my Electric FZR build. Don't really like filming myself. Normally, I just get on with the build itself. But I sat and thought to myself, well, maybe I can help some of you, who want to achieve the same thing. Who want to build a bike. It doesn't have to be an FZR, it doesn't have to be Yamaha, it can be anything that you want. A lot of you on the Endosphere forum are doing e-bikes, your bicycles, and that's cool. I've just decided to go for an electric motorcycle. So I'm going to keep these videos quite short and to the point. I'm not going to waffle around crap and so forth. This is to show you guys how to do it. And if you don't really want to build an electric motorcycle, or you one of those negative pricks that have nothing good to say, then don't watch. This is to help those who want to know how to do this, and I guarantee you'll learn something at the end. So today I'm going to just go through the internals of the Electric FZR, well, what is here, show you some of the components that still need to go into the bike. This is not a finished project, but it will be shortly. The battery box is at the engineers and is coming soon. The reason why I went that route with the engineers is we're dealing with quite a lot of power here. 3 kilowatts of LTO cells. So, I want to obviously make sure that I do that right. You don't have to go through the engineers to do this kind of thing. That's just the route I've decided. You can do this any way you feel is, or that you're comfortable with. So yeah, if there is some interest in me filming these, then I'll continue. If there isn't, well, what's the point? I'll know this and I'll gauge this if there's any likes and subscribes on the YouTube channel. If there isn't, well, then I'll just carry on building this, finishing it and enjoying it myself. So yeah, without further ado, let's get into the internals. All right, let's take off the seat. The tank. And let's have a look at what we have here. Alright guys, so the previous owner, first thing to point out, the previous owner put a lovely purple foot peg, not my favorite color, so that needs to change. But let's have a look first on what's in sight. Okay, so over here, that's the DC to DC controller. Now your DC to DC controller, the reason why it's important is that you're dealing with a higher voltage, a higher system voltage. This is going to be 72 volts. The higher up, basically you get 96. If you look at the Teslas, 300 and something. I'm added, open to correction there, but basically your system voltage is quite high, whereas the bike's internals, the indicators, the headlights and so forth, all works at 12 volts. So we need to step down that voltage, and that's what you use the DC to DC. This is a 72 volt to 12 volt converter, so it allows me to use the bike's battery pack to power, like I said, the electrics that came standard and originally with the bike. The bike is a FZR, sorry, I actually meant to say it's a FZR 250, 89 model. Great bike. I bought it with a blown engine, so, it was already buggered. I'm just bringing life back to it. Okay, so yeah, that's the DC to DC. This is the contactor. Now what the contactor does, think of a relay. All it's doing is it allows a low sort of current, how do I put it, a low current circuit to switch a higher current circuit, and you can see that by these dinky little connectors. This has got a coil, and basically what that does is it opens and closes contactors which is, you know, on this side over here, which is high amperage. This can take a lot of high amperage, which will drive the rest of, you know, the bike, the motor, and so forth. Okay. Then let's go on to the actual motor itself. I don't know if you can see that down there. I'll give you a better shot just now, but basically the motor is obviously your drive unit, which makes the bike go forward. This is a ME1003, but capable of 22 kilowatts if I'm not mistaken, but continuously it'll run at 11.5 kilowatts. This is a permanent magnet brushed DC motor. You get 3-phase electric. I bought this bike in 2013, and at that stage the DC was the best option, so that's why I still have it there. Then onto a controller. As I said, I will do close-up shots. You can see a controller over there. So the reason why you have a controller, think of it this way: if you apply power to a motor, it's full on, full off. If you had to apply just, you know, full power onto this bike, it'll throw you off, because it'll just want to go from 0 to full out instantly. The controller just allows a way. It's PWM, pulse width modulation, and basically what that does is it switches on and off the motor at an incredibly high frequency, and you know, it basically allows you to turn the throttle and adjust the speed at which that motor is turning. Okay, so here we have the motor, the Mars ME1003, 72 volt nominal. Well, that's what it runs at, what you should run it at, but it can go higher. Bolted onto, this is just a motor plate. We use metric here, so that's 10 mils thick, or 10 millimeters thick, and that's the motor plate. It's got a mounting plate bracket over there and there, whoops, there, and there's another one down there. Okay, I had a custom sprocket made. This is a 72 to 12 tooth sprocket. It's a bit small on the front, but I'm just experimenting with the teeth at this moment. So yeah, that'll probably change to probably a 15 or 17 tooth for more speed. You can actually see the pin in there, and then somewhere, can't see it now, there's a set screw which tightens in the actual sprocket. Let's see if I can turn this motor so I can show you guys. Let's see. There it is. So you can actually see that small black dot over here is the set screw which keeps it in place on the actual key there. Okay, onto the controller. Alright, so this is an Ultra Track 7245, 72 volts max, 90 volts. Sort of the same specs as the motor, so it's a good match. Capable of 450 amps, and the motor's capable of 400 amps for a few seconds. So yeah, this is a good controller for this configuration. You'll see that it's got a black circle on the top there. That's basically a comms port to, you know, adjust the actual controller. It's quite a bit that you can adjust. I'll go into that on a future video, but yeah, you can control, you know, your throttle curvature and so forth. All right, there is the 72 tooth sprocket at the back. I got quite lucky with the chain guard there. I didn't have to change that at all. Luckily it just fits on the actual, or over the back sprocket there. Next up, you've got a fuse, quite a big fuse. That is the main fuse. You'll see that it says CNN 400. It's an ANL 400 fuse, and the reason why you have that is if there's any issues on the bike, obviously you need a main safety fuse for the drive system. Let's give you another shot of the contactor. There's the contactor. You'll see I've got a jumper over it at the moment. Let me take that off. The reason the jumper was there is because I was testing earlier at lower voltage and that contactor doesn't engage. The coils don't engage at 24 volts. So yeah, you can see those are quite chunky terminals to handle the amperage. I hope you guys can see that. You'll see there's a resistor, quite a big resistor on there. The reason for that is it bleeds power into the actual controller because the controller has capacitors in it. When you turn on the bike, you don't want that full rush of energy into the capacitors of the controller because you can blow the controller. So what the capacitor does is it allows energy to bleed off into the controller before you start it, so that it's got some voltage and some power in the actual controller, so that when you do start it, it's not a big jolt of energy going into it. I've kept pretty much everything the same. Controls are all the same. You'll see there's a Magura throttle on there. I want to upgrade that to a domino throttle, just because it's less travel to go from 0 to full. So yeah, but I'll use that for now. And there's a couple of things, excuse my messy garage. There's a couple of things I've taken off the actual mirrors. They had paint on. Remember, this is an 89 model bike, so it's 30 years old. I've taken off the mirrors. I'm stripping off the paint on them. Reason for that is the paint's looking a bit shoddy. Yeah, and I'll respray those. I'll try, keep this bike as original as possible. What else have I forgotten? Yeah. Oh, there's a relay over there. I need to upgrade that. I'm just using that for the moment for testing. I want to get a solid state relay in its place, but yeah, it'll be fine for now. That relay is not really rated for 72 volts. So once it's working and everything's tested, I'll upgrade that to the solid state. The reason for that relay over there is you have a kickstand. Let's see if I can show you the kickstand switch. Don't know if you'll be able to see that, but that is a kickstand switch, which kickstand's up at the moment, but that's a kickstand switch. So what I wanted was, if the kickstand is down, these coils over here won't engage. If those coils don't engage, that means power can't go through to the motor and controller. It's just a safety feature. You don't want to be shooting off the mark there and you still have the kickstand down. That could end badly. So all that relay does is, if the kickstand is down, its coils won't engage, which means the contactor coils won't engage, which won't allow the bike to run. Same with the engine stop. That was for the old internal combustion engine. I'm now using that as well to allow for these coils to run, as well as the footstand. So this is like sort of a master switch. If that's not on, nothing will run. If that's on and the kickstand's down, that things won't run as well. Okay, so I will go into the details of the bike a little bit more later down the line, but for now, just a couple of the components on the bike. I'm sure there will be questions and maybe I can do a video on it. What I want to show you guys is, that was just a test pack. There's a funny story to that, but let's put that one side. I didn't talk about the BMS. Now, BMS is a battery management system. Now, you remember I said the motors can handle up to 400 and the controller up to 450 amps. This can handle up to 300. I'm going to just try with this cheap Chinese battery management system. It's received quite a lot of good reviews. So yeah, yeah, there's other BMSs that are out there and so forth, but you know, at 300 amps, 84 volts at you know, sort of max voltage, 72 nominal, I think this will be fine. If not, I can always upgrade it. It's got really awesome monitoring on there. It supports up to 32S. I'll explain why 32S. Remember, if you're doing lithium ion, cobalt or manganese or one of the others, you know, you only need a 20S. If you are doing Life PO4, I think you need a 24S. And I'm going LTO, so LTO requires 32S, or you could do slightly less, but the performance won't be as great on a lower S or serial configuration. Just for those that don't know, S on a battery, so S is the number of cells you have in series, so 32S would be 32. So if I said 32S 1P, that means I got 1 in parallel, 32 in series. Or if 32S 2P, 2 in parallel, 32 still in series. So this is the LTO cell. I'll show you guys in a future video the battery box that's going to actually hold these, which was a pain in the ass. But yeah, this is the cell, or one of the 32 cells that's going to go into the battery box. Yeah, these cells aren't cheap, I can tell you that much. But they apparently have 20,000 life cycles, which is sort of like 54 years if you charge them once a day. Yeah, and they are a little bit heavy, but you know, at sort of, and the energy density is a bit, well, yeah, the energy density is quite a bit lower than the other chemistries. But I don't mind, as long as I can, you know, use this bike for quite a long time. There's quite a lot of charging stations all around me, so this bike will use type 2 charging, obviously with a special adapter. So yeah, yeah, might not. I'm guessing range will be about 40 to 60 kilometers, which is not the most, you know, or the highest range a lot of you have experienced. But I think with the tons of charging stations out there, you know, I think it'll be fine. If not, then I'll just upgrade the batteries later on. The bike will be capable of between 110 to 120 kilometers an hour. I'm not sure what that's in miles. Just, yeah, so I think it's times by 1.6 or divide by 1.6, but yeah, it's about 110, 120 kilometers per hour, which is perfect for me. Just some interesting facts on these LTO lithium titanate batteries. They have a 10C charge and, let me just focus here, charge and discharge rate. So this is a 40 amp hour cell, so this thing can charge or discharge at 400 amps, which is insane. And I was reading some of the spec sheets that for a few seconds you can actually hit them with 800 amps and not have an issue. If you guys explore a little bit on YouTube and so forth, you'll see some of the discharge tests. These are absolutely crazy. Okay guys, so that brings us to the end of the first video. If you guys do want to see more, hit the like button and the subscribe, and that'll give me an indication that you guys do want to see more. If so, what I can do on the next video is just take some suggestions from what you guys want to see, or I can show you how I assemble the battery box, which is arriving later on this week, as well as installing the cells and the battery management system. You know, some of this may seem like it is basic on, you know, installing a BMS. You may know how to do that already, but there are subscribers that don't know, or people that don't know how to actually do that yet. And the point of this is actually to help people. Otherwise, what's the point? So yeah, smash the subscribe and like button if you guys do want to see more. Thanks for watching.